Hello friends, Jim here with Science Talk. Um, in another example of the changing climate, share with you something that may not seem all that significant, but it really is. There was this Arctic cyclone that formed recently, and turning out to be one of the most powerful on record. Now, cyclones occur up in the Arctic on a regular basis. The latest, this storm that I'm discussing with you emerged in the Kara Sea, which is north of Siberia. It drew attention because not just for its size, but for its timing. That's the critical uh, variable I want to stress here, the timing. The storm's central pressure reached a low of 966 millibars, placing it par with the great Arctic cyclone of 2012, which was one of the most extreme summertime storms in recent memory. That storm reached a minimum central pressure of 963 to 966 millibars, depending on which analysis you think is one thinks is correct. The new storm's occurrence, or the recent storm's occurrence in June, was noteworthy because large cyclones such as this one do not normally start hitting the Arctic until late summer. The Great Arctic Cyclone of 2012 spun up in August, as did a major storm in 2016. This was in June, a whole 2 months earlier. Preliminarily, this storm, once they analyze the finished analysis, could rank in the top 10 for Arctic cyclones in June as well as for the summer, June through August, in strength. And this is Stephen Cavallo, who's a meteorologist at the University of Oklahoma. Jiandong Zhang is a scientist at the International Arctic Research Center, University of Alaska Fairbanks, where I worked. His specialty is Arctic cyclones. He mentioned several factors responsible for the storm's formation, including, listen to this carefully, low sea ice cover in the North Atlantic, which has increased the amount of heat in the atmosphere, a strong temperature gradient between land and sea, and a stratospheric polar vortex, an area of low pressure just above the storm. Okay? When you don't have an ice cover, you can pull moisture, right? Ice is not reflecting sunlight back into space, so there's reduced albedo. The ocean, the water is absorbing the heat, so now we have this gradient. The heat is given off and drives the things, right? Drives these storms. Also, I just mentioned the stratospheric polar vortex. This vortex did a downward intrusion and intensified the storm, Dr. Zhang said. Typically, late season Arctic cyclones tend to chew up whatever sea ice is there. You know, kind of crumble it up, whatever, bounce it around, throw it around. What this early season storm will mean for the ice, well, there's still, the data is in, they're analyzing it. The storm was very quick moving, occurred earlier in the season. University of California Irvine PhD candidate Zach Labey said in the communications. Its impacts to sea ice are likely not comparable to these other strong cyclones that occurred later in the summer. Fair point. Labey noted that the early summer storms can favor cooler, cloudier conditions, slowing down the loss of sea ice, which typically bottoms out in September. Okay. There's a lag between what goes on in land and goes on in the ocean. Because of the specific heat content of water, water takes longer to heat up, water takes longer to cool down. Typically, March is the ocean's winter. September is the ocean's summer because of this lag effect. Typically, we see sea ice extent at a minimal in September and a maximum in March. So there's a little bit of a 3-month sliding lag there, if you will. Labby did note that a storm of this strength may precondition the ice for easier melt later in the season. And again, the data is coming in. Zhang said that due to the storm's location, it can transport more sea ice out of the Arctic through the passage between Greenland and Svalbard, known as the Fram Strait. This will contribute to Arctic sea ice decrease, in particular thick ice. Thick ice tends to be that multi-year stuff I've discussed with you before. Storm or not, it's been a kind of a bad year for Arctic sea ice thus far. Very thin, very little of it. Bering sea ice was basically gone by May, months ahead of schedule. Right? The sea ice extents will pass through the Bering Strait. I just did a video with that little graphic based on actual data of what was happening to that little channel off the northeast coast of Greenland, well within the 80-degree latitude region. Well, if you looked over on the other side of the Bering Sea, you can see there's no ice over there. Where typically the sea ice during winter will grow and expand out through the Bering Strait. Not this year. It was gone by May. That's unheard of. Even before the storm took place, sea ice around Svalbard was looking more like it should in September when there's minimal. Arctic sea ice extent for May was at its second lowest on record. This is overall. Second lowest on record. And again, this is according to the NSIDC data. The role of rising temperatures in driving down sea ice is well established. That's undisputed data now. There's also growing evidence that climate change could fuel more ice-shredding cyclones. Meaning, you get more powerful storm, and it breaks up the ice, and when you break up the ice, you increase the surface area to volume ratio, which allows, any contact with warm water to more readily melt. A study published in April concluded that these storms will become more frequent and intense in the future as the contrast between land and sea temperatures continue to rise. I do have an update. According to Cavallo, the storm has officially clocked in as the third strongest June to August cyclone for the region, using what we call the NCEP, the NCAR reanalysis data set, which goes back to 1958. So basically 60 years of data. So we're now seeing some manifestations of other manifestations of climate change in the Arctic. The Arctic is where things are happening most dramatically. Here we have another example of that. So I wanted to bring that to you. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.